Welcome back, folks. In today's class, I'll talk about the 2D problems. 2D problems. Now, before I start with the 2D problems, I'm going to give you guys a recap of what's a 1D problem and how it is different from 2D problem. So if we are along the y-axis, either along x-axis or along y-axis, then that's a 1D problem. So for example, if the object is moving along the east direction or along the west direction, means along, it can move along either of these two directions, west and east, then that's a 1D problem. And same way, if it is a north and the south direction, that's a 1D problem. For example, if a car is moving 5 meters in the east direction, then it moves 3 meters in the west direction. I can simply get the answer by subtracting these two vectors, 5 meters in the east plus 3 meters in the west direction. So the net will be 5 east means positive, west means negative. That will give me 2 meters towards the east because it's a positive number, so I wrote it as east. So that becomes the net resultant displacement for the car. Now, if the object is covering certain displacement along the two axes, what do I mean by that? So if this is the object which is moving like this, now this is covering the displacement not only in east the direction, it is also covering the displacement in the north direction. So let's say this angle is 30 degrees. So, and then it also covers the displacement in east direction. After that, it moves like this. So first of all, it moves in northeast direction, then moves in east direction, or maybe some other direction. Now I wanted to find the resultant displacement in this case. So resultant displacement will be from the origin point to this point. Now, I cannot directly add or subtract the vectors in this case. In the earlier case, I was able to directly add or subtract the vectors. When the vectors become a 2D vector, 2D vector means it's covering the displacement along x and along the y direction. To do that, if I wanted to add this, let's say this was 5 meter and this is 10 meters. If I directly write 5 plus 10 equal to 15 meters along certain direction, that'll be wrong. So that's not how we can add the vectors in two dimension. To add the vectors in two dimension, we have to use the component method. That's one of the ways of resolving the vectors in 2D. So how we approach that? So for example, in this case, this is 5 meters at an angle of 30 degrees. Let me change the color. And this is 5 meter at an angle of 30 degrees, let's say. Now, first of all, we'll learn how to write this. So this is east direction, this is north direction, this is west, and this is south. Now the object is covering a displacement of 5 meter, and then the angle is given to me with respect to the x-axis or along the east direction. So how I'm going to write it? I'll write it, object has covered a displacement of 5 meters at an angle of 30 degrees north of east, because the angle is with respect to the east direction. So I'll write it as north of east. And if the angle was along the y-axis, so something like this, if this angle is 60 degrees, I would have called it as 5 meters at an angle of 60 degrees east of north. I would have written it like this. Now, how to resolve the components of this vector? We're trying to solve this question by using the component method. So if you are given two vectors and they are 2D vectors, at least one of them has to be 2D vector out of the two. So this vector is 5 meter at an angle of 30 degrees. This is east, this is north. So 5 meter at an angle of 30 degrees east, north of east. First thing I have to do is to find the component of this vector. So how can I find the component? I can complete a right angle triangle here. This becomes a right angle triangle. So what is the opposite side in this case? So this 5 meter is the hypotenuse because he covered the displacement of 5 meters. So to find the opposite side, I can use sine theta, and to find the adjacent side, I can use the cosine theta down here. This is sine theta. So the formula will look like sine theta equal to opposite upon hypotenuse. So that will be equal to, this is sine of 30 degrees is equal to opposite is what we are looking for, and then hypotenuse given to me is 5. Sine of 30 degrees 0.5 equal to opposite upon 5, and then opposite value will come across as 5 times, this goes on the other side, 5 times 0.5, which is 2.5. So we got the opposite side. So it means the object has covered 2.5 meters along the north direction. Let me thicken up the pencil. So this is 2.5 meters. But at the same time, the object has covered certain displacement along the east direction also. Now to find that, I will use the cosine theta. So cosine theta is equal to adjacent upon hypotenuse. Now adjacent side is what we are looking for, and hypotenuse is again 5. Cosine of 30 degrees. Cosine of 30 degrees is 0.866. Again, I'll do the calculation on my calculator before writing it down. So cosine of 30, which is 0.866, 866 equal to adjacent upon 5. Now multiplying both sides with 5 cancels out the 5 on the right hand side, and I can find out the adjacent side. 5 times 0.866, which is 4.33, 4.33 meters. So this value of the adjacent side is 4.33. What does this mean? This means the object has covered 4.3 meters along the east direction. At the same time, object has covered 2.5 meters along the north direction too. So we figured out the components of this vector, which was 5 meters 30 degree in north of east direction. Now the second vector which is given to me is, it is 10 meters along the east direction. So this vector, if I draw it on the navigation system, 10 meters. So this is a 1D vector, 10 meters. So if I try and find out the component of this vector, this will be relatively easy. The the x component, because it's in one dimension, so x component will be 10 meters. I can clearly see it's only moving in the x-axis, and y component will be 0 because it's just not moving along the y-axis. Now we have the components of both the vectors, and we will add x components and y components separately. So this was the x component, the adjacent side. This was the adjacent side, and we will add the x components. So net x distance covered will be equal to, you can write it net x here, that is 10 east, which is a positive, and the previous one was 4.66. Let's double check it, 4.33. So 4.33 east. Now both east means both are positive numbers, so 4.33 plus 10 is 14.33 east. Same way, I'll find the net displacement, net dis displacement in y direction. y direction. So net y will be equal to, well, in the second case, there is nothing in the y direction. And in the first case, it was, if I go back and look into the diagram, this was the net y. This 5 belongs to the hypotenuse, so don't confuse yourself. This came out to be 2.5, which we figured out down here, 2.5. That's what we figured out. So 2.5 plus 0, which is equal to 2.5 net y. Now, we figured out both the numbers. Again, this is north because this is a positive number. And I'll again draw the navigation system. And this is east, this is north, this is west, this is south. And I'll try and now represent these two vectors on the navigation system. So this is 2.5, 2.5 in north direction. Other one is 14.33 meters in the east direction. Now I wanted to find the resultant. So what I'm going to do is, sometimes we make a mistake, we end up drawing it like this. So vectors cannot be added this way. So to add the vectors, the tip of the tip of the vector should touch the tail of the other vector. So what do I mean by that? So if this is a vector, this is the tip of the vector and this is the tail. So tip of the vector should match the tail of the other vector. So I have to move this vector from this location down here. So this becomes 2.5, and now I can add these two vectors. So this will be the resultant, and this resultant will start from the origin and end up at the tip of the final vector. So if you would have added it like this, so if this is 2.5 and this is the other vector, let me change the color, this is 14.33, and if you add them like this, then that's going to give you a wrong direction, whereas we can clearly see the object moved somewhere in along the northeast direction. So you can also think of this way, that this completes a square or rectangle, shall I say. In a rectangle, opposite sides are equal, so this 2.5 is equal to this 2.5 and this side is 14.33. So it's not going to make any difference. You just have to adjust it by using the tip to the tail method for the vectors. Now I'm going to find the resultant. I'm going to find the resultant by using the Pythagorean theorem. So this becomes a right angle triangle. Again, I'm drawing it here, 14.33, and this is 2.5, and this is what we are looking for. We can easily find out this number. Resultant square is equal to 14.33 square plus 2.5 square. And then R value will be equal to square root of, well, this is 14, not 1.4. So 14.33 square plus 2.5 square. And if I do the math on my calculator, it will be 14.33 square is equal to 205, 205.3489 plus 2.5 square, which is equal to 6.25. And then I'll add these two numbers, 205.3489 plus 6.25, which is 211, square root of 211.5989, and resultant value will be equal to square root of this number, which comes out to be 14.55. I'm rounding it up to the two decimal places. So the final Resultant will be 14.55 meters. Now I have to find the angle also. Angle, you can use any of the trig ratios, sine theta, cosine theta, tangent theta. It's going to give you the same answer. I'm going to use the tangent theta. So tangent theta is equal to opposite upon adjacent. Now theta value will be equal to, that's what we are looking for, tangent inverse. Opposite is 2.5 divided by 14.33. And if I do the math on my calculator, so it will be equal to 15 point, oops, 2.5 divided by 14.33, which is 9.896 degrees, which I can round it up to approximately 10 degrees. I can call it as 10 degrees. Okay, so the theta value down here comes out to be 10 degrees. So if I have to write the final answer, if I look back here, this gives me the theta angle. So this is 14 point, the final answer comes out to be 14.55. So this is 14 point, I'll write it here. Oops, 14.55 at an angle of 10 degrees, which is north of east direction. So hopefully you understood how we're going to add or subtract the vectors when they are in two dimension. So again, a 2D problem does not mean that both of the vectors have to be in two dimension. Even if one vector is in two dimension, you have to apply the 2D vector approach. So what do I mean by that? In this case, one of the vector was a two-dimensional vector, other vector was one dimension. I still have to apply the 2D approach. Okay, it can be the first vector, which is a 1D vector, another vector is a 2D vector. Still I have to apply the 2D approach in that case. If only if both the vectors are 1D, then I can solve it by 1D. If it is a 2D vector, then one of the method which we've learned today is the component method. We can apply that and solve the question. Hopefully that helps you to understand what is a 2D vector problem, and I'll see you with another video. Meanwhile, if you